All right, this is Chapter 3, Lesson 2, Adding and Subtracting Linear Expressions. Our essential question, how can you add or subtract algebraic expressions? Well, in order to understand, we need to know what a linear expression is. A linear expression is an algebraic expression in which the exponent of the variable is 1. So you can actually see that definition written right here. So you want to copy that up into this spot. All right, an algebraic expression in which the exponent of the variable is 1. So here are some good examples and non-examples. Linear expressions. Notice that we have a variable x here. That exponent, since you cannot see it, is an exponent of 1. We just don't have to write it. In the next one, 3x plus 5, again we see the variable has an exponent of 1. And in the next one, 5 minus 1, 6x, this x has an exponent of 1. So these are examples of linear expressions. Now we're looking at nonlinear expressions. We have an exponent of x here, but now since the exponent is a 2, that's nonlinear, meaning not linear. In the next one, negative 7x cubed plus x, since this x has a cubed exponent, it would be nonlinear. And in x to the 5th plus 1, since this exponent is a 5, that is a nonlinear exponent. But what we're going to talk about now is adding these linear expressions. Finding the sum. And there's two ways of doing it. You can do it vertically or horizontally. Remember, vertically, up and down, versus horizontal, left to right. In the first one, I see x minus 2 plus 3x plus 8. And I know that this is linear because these x's have an exponent of 1. So we're going to add these. If you want to do it vertically, you're going to line them up. X minus 2, and then 3x plus 8 below it. We are adding them. I have my addition sign out there. And notice that my like terms are vertical to each other. I've got my x on top of my 3x and my negative 2 on top of my positive 8. So I can look at it as negative 2 plus positive 8 would give me a positive 6. My signs are different. And in addition, I actually subtract and take the sign of the higher absolute value. And this is really a 1x plus 3x would give me a total of 4x, giving me my answer of 4x plus 6. If I want to do it horizontally, I'm going to rewrite it over here. X minus 2 plus 3x, 3x plus 8. I'm really just looking for those like terms. So if you remember in previous lessons, we put shapes around our like terms. This is a positive 3x. That sign is now gone. And then we've got a negative 2 and a positive 8. And I'm going to rewrite the problem horizontally with my like terms together. So I've got my x plus 3x and negative 2 plus 8. X plus 3x gives me 4x. Negative 2 plus 8, I'm adding with different signs, therefore I subtract, which would give me 6, and take the sign of the higher absolute value, which is the positive 8. 4x plus 6. Notice both answers are the same, whether you do it horizontally or vertically. The key part here is looking for those like terms and either lining them up vertically or putting them together horizontally. Take a look at another one like that. And again, we'll start with our vertical. I'm going to rewrite it down here. Negative 4y plus 3 plus 11y minus 5. My y's are on top of each other, and my constants are on top of each other. Positive 3 plus negative 5. I'm adding, and my signs are different, therefore I'm really subtracting and taking the sign of the higher absolute value, which would be my negative 5, so it's going to be a minus 2. Negative 4y plus 11y, again, I'm adding different signs, so I'm really subtracting. 11 minus 4 is 7y. Take the sign of the higher absolute value, which would be that 11, making it a positive 7. So we have 7y minus 2. If you want to do it horizontally, I'm going to rewrite it again over here. Negative 4y plus 3 plus 11y minus 5. I'm going to look for my like terms. I'll start with my y's. I've got a negative 4y and a positive 11y. Notice that I took that positive sign with the 11y. Then I have a positive 3 and a negative 5. I'm going to rewrite it with my like terms together. Negative 4y plus 11y, positive 3, and a negative 5. Again, putting these y's together, I'm adding and my signs are different, therefore I'm really subtracting. 11 minus 4 is 7. The y comes down. 11 has a higher absolute value, therefore I take that positive sign. Positive 3 minus 5 is really a subtraction problem. So we can really think about it as keep change opposite, which if you want to do it like that, 3 plus negative 5. I have a positive plus a negative. My signs are different. I'm really subtracting, which gives me 2. Taking the sign of the higher absolute value, which would be here because 5 has a higher absolute value, giving me a negative 2. 7y minus 2 and 7y minus 2 for both answers, they are the same. Now I'm going to look at some on your own problems, both being addition. You choose. Do you want to do it vertically? Do you want to do it horizontally? Do it both ways and check to make sure that you have the same answer. That's also a great idea. Right now I want you to pause the video, try these two problems on your own, then come back and check your work. I'm going to show you both ways of doing it. I'm going to start over here with vertically. X plus 3 plus 2x minus 1, positive 3 plus a negative 1. Different signs, meaning we subtract, take the sign of the higher, which would be that positive 3. 1x plus 2x gives me 3x. So we're looking at 3x plus 2 for number 1. Horizontally, going straight across, I'm just going to use the original problem. I've got an x and a positive 2x. And then I've got a positive 3 and a negative 1. I'm going to rewrite the problem with my like terms together. X plus 2x plus 3 minus 1. X plus 2x gives me 3x. And a 3 minus 1 would be a positive 2. Both ways of doing it yields the same answer. Number 2, start vertically. Negative 8z plus 4 plus 8z minus 7. One thing I notice here, I have a negative 8z and a positive 8c. They totally cancel each other out or give me 0. Positive 4 plus a negative 7, my signs are different. I would find the difference between them, which is 3, and take the sign of the higher absolute value. I forgot to bring down my z here. So I have 0z minus 3, which really 0z, anything times 0 is 0, so we can just get rid of that for a final answer of negative 3. If I want to do it horizontally, I've got negative 8z plus 8z. Opposites cancel each other out. Positive 4, negative 7. So I'm looking at negative 8z plus 8z, opposites, plus 4 minus 7. Negative 8z, positive 8z, still a 0z. 4 minus 7, we could rewrite it to help you with your integer rules as 4 plus negative 7. My signs are different. I subtract and get 3. Take the sign of the higher absolute value, which would be my 7, which is negative. 0z minus 3, anything times 0 is 0, so we can just get rid of that, gone, for an answer of negative 3. In the next example, notice that we have a number that's on the outside of those parentheses. So before we can add these linear expressions, we must use the distributive property first. And to remind yourself of that distributive property, you are multiplying everything in the parentheses by the number that's on the outside. So what we're distributing here is the 2. We're going to do 2 times negative 7 and 5/10 z, and then 2 times positive 3. We're going to multiply that out. That would give me a negative 15z when I do 2 times negative 7.5, negative 15z, and 2 times positive 3 gives me a positive 6. And then the rest of my expression, bring it on down, plus 5z minus 2. There's no number outside of there, so there's nothing to distribute to get rid of those parentheses, so we can just kind of get rid of them. I now have a linear expression going across. I'm going to do this one horizontally since it's already written horizontally. I'm just going to take care of those like terms. Negative 15z plus 5z, and a positive 6, as well as a negative 2. And then I'm going to rewrite it with my like terms together. Negative 15z plus 5z plus 6 minus 2. Negative 15z plus 5z, my signs are different, therefore I subtract. That would leave me with 10z. Take the sign of the higher absolute value, which is here. Leaves me with negative 10z. And I have a positive 6 minus 2, which is a positive 4. Negative 10z plus 4 would be my final answer there. If you wanted to do it vertically, you could as well. Negative 15z plus 6 was my first expression, plus 5z minus 2, my second expression. My like terms are lined up vertically. Negative 15 plus 5, my signs are different, therefore I subtract, take the sign of the higher absolute value, which would be the 15, negative 10z, and 6 plus negative 2, my signs are different, therefore I subtract and take the sign of the higher absolute value, which would be my positive 6, and 6 minus 2 is 4. Again, we get the same answer whether we do it vertically or horizontally. So right now, I want you to take a look at the on your own problems. Notice if there is a number on the outside of your parentheses, you must distribute it first. In the first problem, there's only one that needs to be distributed. But in the second problem, you are distributing 2 different numbers. Doesn't matter that they're fractions, you're still just multiplying it out. Follow that distributive property and then decide whether you want to do it vertically or horizontally and combine those like terms. Pause the video now, try those 2 on your own, and then you can come back. Okay, for number 3, I need to distribute my 2. Positive 2 times negative 5n. Different signs give me a negative 10n. Positive 2 times positive 3 gives me a positive 6. I can then bring down the rest of my expression. 4 minus n, and I have a minus 10n and a plus 6. I'm then going to look for those like terms, put some shapes around them. I got a positive 4, positive 6, a negative n, and a negative 10. I'm going to rewrite them with my like terms together. 4 plus 6 minus n minus 10n. 4 plus 6 would give me 10. Negative n minus 10n. When we subtract, remember we add its opposite, so that becomes negative n plus negative 10n. A negative plus a negative is a negative. 1 plus 10 would give me a negative 11n. And sometimes we like to write these expressions where the variable comes first. So if I want to switch the order around, I still have my negative 11n, and this 10 is a positive 10, so we would write plus 10. Both of those answers would be correct. In number 4, I need to distribute the 1/2 to everything first. 1/2 times w would be 1/2 w. 1/2 times a negative 6 would give me a negative 3. Remember, we're following those integer rules. Positive 1/4 times w would be a positive 1/4 w. Positive 1/4 times positive 12 would be a positive 3. I'm going to stick with the horizontal, go right to my like terms. 1/2 w plus 1/4 w, negative 3 plus 3. Rewrite them with my terms together. 1/2 w plus 1/4 w minus 3 plus 3. 1/2 plus 1/4 would give me 3/4 w. And negative 3 plus 3 takes me back to 0. And since I'm just adding 0 here, my final answer can just be 3/4 w. All right, looking at the next examples, we're now going to move on to subtracting linear expressions. Okay, moving on to subtracting linear expressions, I added some notes here that you should probably copy in. For subtracting linear expressions, to subtract one linear expression from another, add the opposite of each term in the expression. Now we've heard add the opposite before. That's just part of your integer rules. When we subtract integers, remember we do keep, change, opposite. We add the opposite. Here you're going to be adding the opposite of every term in the expression. So you're not only changing this subtraction sign to addition, you're also changing all of those signs in the second linear expression. And then again, you can use your vertical or horizontal method. One thing we need to pay attention to here is what I added on. It says when a number needs to be distributed in the second expression, sorry, I just left off the IO in there. In the second expression, be sure to distribute a negative number. Then go right to your like terms. So that applies right here, where we see this negative 2 on the outside here. We're going to distribute a negative 2 to each of these terms, and then we can go right to our like terms. In part A, we're just going to follow this top part. We're going to do keep, change, opposite, where we're going to add the opposite of each term in the expression. Therefore, I'm going to start with A. I've got 5x plus 6. That would be my keep. My subtraction needs to be turned into an addition problem, plus, and then we're going to go with the opposite of all of these guys. So the opposite of negative x is going to become positive x, and the opposite of plus 6 would be minus 6. Now that I did my keep, change, opposite, I'm going to go right into looking for those like terms. So I can see here I have a 5x and a positive x. Notice if you want to hear, you have a plus positive x, which is just plus x. And then we have positive 6 and negative 6. I'm going to take those like terms and rewrite them across. 5x plus positive x can just be plus x. We have plus 6 and minus 6. 5x plus x, 5x plus 1x would give me 6x. Positive 6 minus 6 takes me to 0. Remember, when we're adding 0 to anything, we're just left with 6x. Here's the part where it gets a little bit trickier. Since this term on the outside here needs to be distributed, we're going to distribute a negative 2 to everything. That way we can go right to like terms after that. So 7y plus 5 is going to remain 7y plus 5. That's my keep. So my change is when I'm actually distributing first. So negative 2 times 4y would be a negative 8y. And negative 2 times negative 3 becomes positive 6, because a negative times a negative is a positive. So from there, I don't have to go to keep change opposite. I'm going to go right to my like terms. Looking at my like terms, I can see that I have 7y and negative 8y, and then positive 5 and positive 6. So please make sure that you wrote this down in your notes to remind yourself that if you distribute that negative number on the outside, that takes care of the keep change opposite part. So after we distribute a negative, we can go right to like terms. Rewriting my expression across with my like terms together, 7y minus 8y plus 5 plus 6. 7y minus 8y is the same as saying 7 plus negative 8. Keep change opposite. That would give me 1y, that would have to be negative because we take the sign of the higher absolute value after we subtract because my terms are different. And positive 5 plus 6 gives me a positive 11. And since that's a 1, we could actually just write that out as negative y plus 11 as well. That 1 can always be invisible. All right, so no distributing, you go right to here, keep change opposite. If we're distributing, such as in B, you distribute that negative, and then you can go right to your like terms. So right now, you're going to try some problems on your own. Right, in the first one, number 5, there's nothing to distribute, so you're going to do your keep change opposite. In number 6, notice you have 2 numbers to distribute. Distribute that negative 2, got everything. Distribute your negative 5, then go right to your like terms. Right, distributing and then like terms. So pause the video here, work those problems out, and then you can come back and check. All right, so in number 5, we're going to do our keep change opposite. So m minus 3 stays as the same. That's your keep. We change from subtraction to addition, and then we do the opposite of the whole second expression. So the opposite of negative m is a positive m, and the opposite of positive 12 would be negative 12. I'm now going to look at that and find some like terms. So I'll start with my m. If I put a circle around m, I should also be circling this positive m. And if I put a square around negative 3, I'm going to put a square around negative 12. And then I'm going to rewrite my problem with my like terms together. So we have m plus m. I don't have to write that positive sign twice. We know that when we're adding a positive, it's just adding. Minus 3 minus 12. M plus m, 1 plus 1, or 2m. And negative 3 minus 12. If I want to do keep change opposite there, negative 3 plus negative 12. Now I'm adding and the signs are the same. That would give me a negative 15. Final answer, 2m minus 15. In number 6, you have to distribute. So since I'm distributing a negative here, we're going to do that and then go right to our like terms. There's no point in doing keep change opposite because we're doing that as we're distributing that negative number. First, we're going to distribute the negative 2, though. Negative 2 times c is negative 2c, and negative 2 times positive 2.5 would give me a negative 5. Then I can distribute my negative 5. Negative 5 times 1 and 2/10 c is a negative 6c, and negative 5 times a positive 4 would be a negative 20. Now I'm going right to my like terms. So if I put a circle around negative 2c, I'm also going to circle negative 6c because they have that c in common. And I'll put a square around negative 5, and I'd also square the negative 20. They are my constants. I'm going to rewrite it with my like terms together. Negative 2c minus 6c minus 5 minus 20. Negative 2 minus 6, keep change opposite there, would give me a negative 8c. And negative 5 minus 20 is like saying negative 5 plus negative 20, or negative 30. I'm sorry, negative 25. So final answer, negative c minus 25 would be what you get. So just to reiterate that, nothing to distribute, use keep change opposite. If you only have to distribute the number here, then you would still use keep change opposite. Remember, it says if you have to distribute in the second expression, you're distributing a negative number, therefore after you do that, you're going to do your like terms. Let's take a look at the real life application problem. The original price of a cowboy hat is $D. You use a coupon and buy the hat for D minus $2. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat. Interpret the expression. So it says here, to find the earnings, you're going to do your selling price minus your purchase price. So if we look up there, it says we buy the hat for D minus 2. If I'm buying it for D minus 2, that would be my purchase price. That's what I purchased it for. Then it also says that we sell for 2D minus 4. So that would be my selling price. When I do that subtraction, that'll give you my E earnings. So my earnings, if I look here, I have nothing to distribute. I'm going to go right to keep change opposite. So 2D minus 4 would be my keep. I'm going to change from subtraction to addition, and I have to do the opposite of that whole entire second expression. The opposite of D is negative D. The opposite of negative 2 would be positive 2. I can now look for my like terms. I'm going to put a circle around 2D and negative D. And I could square my negative 4 and positive 2, and then rewrite the expression with your like terms together. So we have 2D minus D minus 4 plus 2. 2D minus 1D would give me a 1D. Negative 4 plus 2, we are adding and the signs are different, therefore we subtract to get 2. Take the sign of the bigger absolute value. We're looking at 1D minus 2, or simply just D minus 2. We don't necessarily need that 1 there. So they're asking us to interpret that expression, D minus 2. Well, if I look back, I can see that I actually paid D minus $2 for the hat. And if my earnings are D minus 2, that pretty much means that I doubled what I paid for it. Right? Or I paid D minus 2 for the hat, so I doubled my money by selling it for twice what I paid. So what does it mean we doubled our money? So see if you can try the on your own problem. Notice it's saying to find the difference, which always means to subtract. The question states, in example 4, you sell the hat for D plus $2. How much do you earn from buying and selling the hat now? So they just changed your selling price. You can go back to the original expression, this guy that they gave you. To find your earnings, you're doing selling price minus purchase price. See if you can set that one up and solve it. Pause the video and come back and check your work. So now for my earnings, I've got my selling price, which we now see as D plus 2, minus, we're finding the difference, my purchase price, which was D minus 2 as well. Nothing is being distributed, so we can go right to keep, change, opposite. D plus 2 is my keep. We change from subtraction to addition. We change the opposite of each term in my second expression. The opposite of D would be negative D. The opposite of minusing 2 would be to add 2. We can now look for some like terms. D minus D, positive 2, plus 2. Rewrite it with your like terms together. D minus D, plus 2, plus 2. D minus D would just give me 0. 2 plus 2 would give me a positive 4. And 0 plus 4. 0 plus 4 would be $4, so I earned $4 there. So that one makes more sense because there's no variable involved. You just made $4 by selling it for D plus 2.